Hey students, welcome to
Okay, the coolest chemistry podcast out there.
Isaac here, with my partner Joe, as always.
It's Taco Cat, and today we're going to be studying the topic of equilibrium.
Wait, Taco Cat?
Well, for today, I'm going to be referring to myself as Taco Cat. You see, it actually has a lot to do with equilibrium. Equilibrium is when the forward reaction equals the reverse reaction, and Taco Cat can be spelled the same forward or backwards.
Well, that's a great explanation, Joe. Isn't there an analogy for that too?
Yeah, Isaac, there is. Imagine two people on a sidewalk, both walking in opposite directions but at the same speed. The point where they cross is equilibrium. If that visual wasn't good enough for you, maybe this one will help.
The white ball represents a forward reaction.
The black ball represents
The reverse
the
reaction.
reverse reaction. Wash.
So, Joe, what if...
I mean Taco Cat.
No, I mean Joe. What if I want to find the value for the reaction quotient when the reaction has reached equilibrium?
Isaac, that's easy. You just use the equilibrium constant K.
I think you're right, Joe. Give me the magic formula, buddy.
Your first step is to write the equilibrium expression for the reactant. Next, you just plug in the concentrations and make sure they are at equilibrium. And lastly, you just solve for K.
The K expression is written products over the reactants, where the coefficients in the equation become the exponents.
In this example, you'll notice it's products over reactants, but H2 is not included because no liquids can be put in equilibrium expressions.
Well, Isaac, gases and aqueous solutions only affect equilibrium. Pure solids and liquids do not. Leave solids and liquids out of the equilibrium expression.
So, Isaac, I noticed you spelt your name kind of funny. Why is that?
Well, you don't get it yet? Isaac. It's a lot like ice box. You know, an ice box has a lot to do with equilibrium. Duh.
Can you show me an example?
Yeah, man. ICE stands for initial concentration, change in concentration, and equilibrium concentrations. Here is an ice box. You plug in the initial concentrations for the reactants into the ice box. The X values are related by the coefficients in the balanced equation. You solve for X by plugging the equilibrium amounts into the equilibrium expression.
Once X is found, plug X back into the equilibrium expression.
Let's talk about another important part about equilibrium.
And what would that be, Isaac?
I think it's Le Chatelier.
You mean Le Chatelier's principle?
You know what? I think that's what I mean.
What is that?
Well, let me tell you, Joe. If a system at equilibrium is disturbed, then it will shift its equilibrium to oppose the change. A reaction can be disturbed by changing concentrations, temperature, or pressure.
If you're confused, let this analogy help you. If someone's hair is too short, then products or extensions must be added to make the hair the right length. If hair is too long, then reactants must be added to the hair, cutting the hair to make it the right length. For concentration, when you increase the reactants, the product shifts right. When you decrease the reactants, it shifts left. When you increase products, it stays left. And when you decrease the products, it shifts right.
In an exothermic reaction, when temperature is increased, it shifts to the left. When temperature is decreased, it shifts to the right. In an endothermic reaction, when temperature is increased, it shifts right. When temperature is decreased, it shifts left.
For changes in pressure, pressure only affects equilibrium when the reaction has an unequal number of moles of gas on each side. For increasing pressure, if there are more moles of gas, it shifts the reactant side to the right, but the product side to the left. For decreasing pressure, if there are more moles of gas on the reactant side, it shifts left, but right if there are more moles of gas on the product side. Well, students, I hope today's podcast has been both fun and entertaining, informative,
Educational?
educational, whatever you want to call it. Now enjoy today's jingle.
Equilibrium, K is the constant, K equals AB over CD.